Hi MIP 611. Today I'm going to teach you a little bit more about nested PCR for the first local expert project, and this is for Module 1. So to start, we're just going to go over nested PCR, a little basic overview, and if you're interested in learning more about anything I talk about on each slide, the video or article where I learned more about the topic is linked on the slide. So to start, just a little overview of nested PCR, but the good thing is you already know more about it than you think you do, because nested PCR is simply a modification of the PCR that we've studied in class to increase specificity and sensitivity of the reactions due to its requirement for 2 primer sets and 2 successive PCR reactions. You will still have 2 forward primers and 2 reverse primers. So you have quite a few advantages of using nested PCR, such as overcoming nonspecific amplification, as well as you're decreasing the chance of false positives since you do have those 2 reactions with 2 sets of primers. So because of that increase in specificity, nested PCR is much more useful in genes that you don't see as often, so your more rare genes or templates that are particularly challenging. The need for 2 sets of primers, though, can also be a limitation because it is very expensive, or at least can be, and will be a little bit more time consuming. And then the nested PCR's need for 2 reactions increases the chances of contamination and human error. So just be aware of that in your reactions. Now, like regular PCR, or the PCR we've studied in class, nested PCR can give us both false negatives and false positives, so it's important that we control both. Like in traditional PCR, running a control without a template should show you nothing on your gel, and you can also run a positive control with primers that you might have had success with during previous reactions. Since nested PCR is a type of PCR, it has many applications to our first module, including its applications for cloning and DNA detection. However, unlike the PCR discussed in Module 1, nested PCR requires the design of 2 sets of primers. The first round, which is your outer primers, are then used in the second round, which are nested primers, as your template. So just be aware of that and make sure you're using the correct primers when going to your second reaction. Here is an example of nested PCR strategy where the dots represent DNA sequences of unspecified length and the lines are just to represent the distance. Your bases, your A's, T's, C's, and G's, are going to show up in your PCR primer binding sites. However, in reality, these would be much longer. This is just to show you an example of the binding sites. Here is another example of nested PCR where you can see your outer primers and your nested primers and each successive reaction. So your top strand right here is, of course, your first PCR reaction, and then it shrinks into your second round, which then gives you your final product. We also talked about vector-borne diseases in our discussion with Dr. Trammell during the first scientist presentation. So I thought I would include a little bit about nested PCR and vector-borne disease. And actually, you can use nested PCR to better detect malaria, which is obviously from mosquitoes. And you can see that nested PCR helps us detect malaria in infected patients more quickly and more efficiently. This is going to be our last slide. Thank you all for listening, and I hope you learned a little bit more about nested PCR.